Good afternoon. Welcome to this week PEwise Hour. This week the question is about pump in series and determining the total discharge. So each pump um, creates a head, and also you have a head loss depending on how much um, flow you have through that pump and depending on the setup. And the um, total flow comes out of where how much you add the head and how much you have head loss. When these two are in equilibrium, then that's the amount of flow rate that you get out of a pump. So this question has two pumps in series. Um, Let me draw. You have the pipe, you have one pump, again pipe, and you have another pump. And when you have pump in series, if the added head is H1, the first one, and added head in the second one is H2, then the total added head H sub T is equal to H1 plus H2. So, and the Q in the first pump when it is a series is equal to Q in the second pump. So we can use these two ideas to calculate the total flow in this question. The question reads, two pumps are operated in series in a water distribution booster station. The characteristic curves for the two pumps are shown below. The system's total head loss as a function of flow rate is given in the table. What is the most nearly total discharge at the operating point of the combined pump curve? So this chart gives us how much head loss we have in this whole system. Let's call it H sub L. And the discharge is when the amount of head added by these pumps is equal to this head loss. Um, the easy way to calculate this is at different points, we add the head of these two pumps, draw the total head, and then we also draw the total head loss and see where these two curves cross each other. And we can do this in the range that the question has given us because probably that's where we have the answer. So let's start by 42. At 42, this is the head, the added head in the first pump. This is the added head in the second pump. So let's say it's 47 and 65. 132. So it's some point here for the first point. Then at 50, we have 38, let's say, and 60, it will be 98. So the second point is here of the total head. 58. So this is like 38. This one is also 52. So 90. This is 90. And 64 here for the first one. And this is for the second one, the head added. So 20 plus 50, you will have 70. So as we increase the, oh, this is bad. Let me use a tool. Line. As we increase the capacity, the amount of head that these pumps can add is reduced, which makes sense because the pump has a certain power. When you add the capacity, it cannot add head to the same amount. So with increasing capacity, the added head decreases. At the same time, with increasing capacity, the head loss increases. So these two lines cross at some point. So let's plot the head loss. At 42, it is around 80. So for this first point, it's here. At 50, it is 82. So the slope is much smaller. So this one was 78, 82, 85 at 58. 85 is around here, and 87 at 64, and 90 at 70 here. So if we draw a line for the head loss, these 2 points cross at near 55. So do we have? Yes, exactly. Option B is the answer. So to solve this question, you need to have an idea of how pump in series work. You should remember that the total head added because of the pumps is the sum of the heads that each pump add. And another point to remember for solving a question like this is by increasing the capacity, the head that each pump can add decreases. At the same time, by increasing capacity, the head loss increases. So these 2 points have an equilibrium, and that's what the capacity that you get out of a system. And the rest is just drawing the points on the chart and finding the intersection. And usually they give the values in a way that being wrong by a little bit doesn't hurt. You can find your answer in the options. I hope this question was helpful, and let us know if you have any question. We can go over it during the next week, PEwise Power Hour, and I wish you the best of luck for studying for PE. Bye.